Greetings all LinkedIn professionals. Today I would like to share my wonderful learning experience on triggering the system daemon Linux services for the Kafka cluster, like starting the controller, starting the broker, stopping the controller, stopping the broker, and also to know the status of the controller and broker in the Angular GUI in a more secured way using SSH known host and authorized keys. If you see, this one is where my Kafka controller is running, which is a bare metal, and this is where my brokers are running, which KVM1 and KVM2. The status is showing in the Angular GUI as up. My goal is to bring all the infrastructure components under one umbrella, which is the Angular micro front end. If you see one gateway, which I just started exploring, and one Kafka and Kubeshift. And now this is the pod that is running under the namespace one Kafka, one infra Kafka as a backend microservices running on the Micronaut framework. This is a holistic view of my Kafka cluster, where on the bare metal controller is running, broker 1 and broker 2 are running on the node 1 and node 2, and the application Java Micronaut Service is running on the node 2. My end goal is to start and stop the cluster services in a more secured way, right? This needs the system resource access. Okay, so where do these custom system D resources, daemon services live in Linux? They all live under HC systemd system folder. Okay, which node components contains what? Basically, your goal is to start or stop the controller service, or to know the status of the controller service, to start or stop the broker service, to know the status of the broker from the pod terminal, right? Or from the pod via Java service. If you want to have that authority, you should have the certain access control in place. One is the authorized key, another one is the known host. Known host is for interactive mode. This is the crux. Which components or node contains what? Kafka controller, which is running on the bare metal, it contains the authorized keys for Java backend service pod. Authorized keys means the public key. Okay, and the Kafka controller systemd service. Likewise, is the same for the Kafka broker as well. And then on the pod side, right, Kubernetes, the Kafka Java microservice running as a Kubernetes pod on node 2, it will contain Kubernetes secret. Okay, basically when you want to run it on the Java for starting and stopping the system services, you should go in the non-interactive mode, right? Because it's all the Java that is taking care. So if you want to go in a non-interactive mode, you should have the known host. The known host is nothing but it will contain the fingerprints of all the servers which you want to connect. So this will avoid any kind of middle man in the middle attacks. Okay, so fingerprints, again, these fingerprints will not leave out of the Kafka pod, right? The Java pod. They, when you, whichever the host you want to communicate, those fingerprints are compared against the one which you are going to communicate, the server. If they match, then it will communicate. If they don't match, it will prompt you, are you sure you want to connect, right? But you are running it as a service, so you have to pre-configure them. And then the private key, this is a private key used by the pod to authenticate the bare metal, right? Again, the private key will not leave the pod. The private key, when the service is running, it will extract the public key out of the private key. That public key, when it communicates, if it matches on the server side, it will throw a challenge to the client, which is the pod right here, the Java service. And this Java service is going to resolve the challenge via private key and if it challenge is resolved, then the authentication will happen. Now, one important thing, any of this secured information, if you want to pass it to the Java service which is running as a container in the Kubernetes worker, you need to create a secret. So what are the two secrets, two secured information which we are providing to the Java service? One is the private keys, second one is the fingerprints of the known hosts, right? Known servers. So these two you need to create a secret. But when you want to architect and build a GUI, so typically how do you get the secrets from the backend? You get the secrets from the backend using the kubectl get secrets, right? Same thing, now you are making the Java to execute the kubectl get secrets and displaying the same on the Angular micro frontend. So two things, you have to create the secret. Secret for what? Secret for known host, secret for the private keys for the pod. So using this information, the backend will do all the magic to get into the host shell terminal and trigger the Kafka cluster services. So this is the one that lists, because these secrets are for what? These secrets are for one Kafka namespace. One secret is for connecting the Postgres DB. Another secret is for the SystemDServices. Two secrets here. You can see that here. These secrets will go to the deployment YAML, right? And whatever the properties file that are present in your actual Java application, that are going to be part of the kube configs. Next, this development and end goal is to have the secured communication across clusters or within the clusters, develop a service mesh using proxy envoy and various other open source softwares are there, right? Still I'm exploring, and build a gateway using Golang and Micronaut.